To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.
So my dear children, in the earlier chapter we discussed about the process of electroplating. Actually in the earlier chapter, finally at the final parts, like in the final 20 minutes, I gave you the introduction for the process of electroplating by doing a simple experiment. Now within this chapter we'll be exploring more things related to the electroplating process, right? So let me remind you the earlier experiment that we have conducted. The earlier experiment was we plated a certain metal. Here we used the copper metal to plate on a certain different object, right? So over there, when I was like touching the object, I can see that my fingers are having that particular metal. Over there it was copper. So it seems that, now I told you that during the process of electroplating we are going to plate a certain metal on it. Okay, so when plating that particular metal, it should be firmly fixed, or it should be firmly adhere to the particular object. But however, in that time, or when I was doing the experiment, I could clearly observe that when I am touching it, it was not adhere to the object. It is going to wipe off, or we can wipe it off without any trouble. That means it's not being fixed with the particular object very firmly. That means, my dear children, the electroplating process which we carried out in our laboratory was not successful. It was not very successful. That's why it's going to happen. So let's see what are the reasons for it. So within here we'll be discussing about how to get a more quality electroplating process. Okay, let's see what are the things given then. So take the iron nail. So here actually we use a different object over there. So you used in the activity to your hand and touch its plating with your fingers. So you need to touch it with the plate, touch it. Okay, so actually I did that thing, and you could clearly observe that the metal plate or the copper is going to remove. So here it is given, you will observe that the copper plating will get removed from the nail and comes to your fingertips. This shows that the plating occurred in this way is not in good quality. High quality plating occurs when the electrochemical change take place very slowly. This is important. High quality electroplating occurs when the electrochemical change take place very slowly. If this electrochemical change, it is referred as an electrochemical change because a chemical change is resulted by using the electricity. Okay, so here during the electrochemical change which occurs in the process of electroplating, the process of electroplating should happen, or it should occur very slowly. It should occur very slowly. So over there, when I was doing the experiment, my dear children, I took a greater, or else I gave a higher potential difference. That means more current is given out to the circuit. If more current is given out to the circuit, then the process will occur more faster. If the process is going to occur more faster, if the plating process is going to occur more faster, then in that case, my dear children, there are going to be a trouble. The trouble is that a quality process of electroplating is not going to occur. Okay, a quality process of electroplating will not occur. Okay, that is why when you when you keep, or when you touch the particular object, the plating is going to come off with your fingers, right? So it's important to make, or it's important to do the activity or do the experiment, or to provide the current to the experiment in a slow manner. That means we have to provide it with the low potential difference. The potential difference that we are going to provide for the particular electric circuit should be very low, I mean, it should be able to activate the process of electrochemical change, right? And that activation, I mean, like the current or the potential difference that we are going to provide for the circuit should be at a minimum level, right? It should be at a minimum level. That means we'll imagine that the voltage needed for the electrolysis process is 1 volt. Then we have to provide 1 volt, that's it. If you provide more electricity or more potential difference, then the quality of the electroplating will not be as will not be like the way that we need. Okay, the quality will be reduced. So you have to provide the minimum current needed for the process of plating. That's the first main thing. So by that way, we can slow down the process of electroplating. If the electroplating process is occurring more slowly, then the quality is high. Okay, remember that. Then the electrolyte, the salt solution used for this has to be very dilute. The next condition, the electrolyte or the salt solution which is going to use or which has been used should be very dilute. Dilute means we have to add more water. Okay, dilute means we have to add more water. Actually, when we are doing the we are doing the experiment, the copper sulfate solution with the copper sulfate solution, the color of the copper sulfate solution was light blue. Why it need to be light blue? Because to have a quality plating process. However, that won't matter if you are going to provide more electricity. Okay, providing more electricity is not suitable for the experiment, I told you. However, when you are using the electrolyte should be very dilute. It should be very dilute, right? Very dilute means you have to add more water, right? If it is a copper sulfate solution, then the color of the copper sulfate should be very light blue, my dear children. Okay. Then the next one, the chemical change occurring can also be showed down by passing a very low current through the solution. This can be effected by applying a low potential difference. So like I said, it's very important to provide very low current. How to provide low current? By applying or by giving a very low potential difference. So by giving out a low potential difference, right, you need to provide low current to the circuit. By that way, my dear children, we can slow down the process of electroplating. If the electroplating process is slowing down, then the quality of the plating process is going to be very high. Okay. Next one. In chemical industries, high quality electroplating is done by controlling the conditions appropriately. Plating of metals like nickel and chromium on iron trays is an example. This gives a beautiful silver appearance to the tray. So the next thing, why do we need to electroplate certain object? It's mainly because to have an attractive look, right? To have an attractive look, we electroplate different other metallic objects by using a different color, different metallic color, right? Actually, we use the metal so that the metallic color is getting plated on that particular object. Let's imagine like this. Now, I have a spoon. So, the spoon is made up with metal. Let's imagine that it is iron. So, you know that iron is going to rust very quickly. So, we need to plate this spoon with chromium or nickel. Chromium and nickel is somewhat resistant to corrosion. So, when plating these things with chromium or nickel, what will happen, my dear children? We can get a good attractive look, and it is also resistant to corrosion, right? So, electroplating is mainly carried out by industries in order to give out a good appearance, an attractive look for the objects. And the other thing is that electroplating is carried out, right, for the objects, or electroplating is given electroplating, right? Electroplating is carried out in order to give out or in order to protect objects from corrosion, mainly metallic objects. So we can do electroplating in order to protect from corrosion. A good example for that procedure is galvanizing. We can galvanize iron by using zinc. Here we use the process of electroplating, right? So in that case, my dear children, what will happen? In that case, you can protect the iron because zinc is going to give out a protection for the iron, because zinc is more reactive than iron. So zinc plate is getting corroded, but however the iron is getting protected. Okay. So electroplating is carried out by industries in order to give out an attractive look, right? Then to have a good or else a wonderful appearance with a good color, then to avoid from corrosion. Okay, it helps to avoid from corrosion. So these are the special key points, right? Or these are the benefits of electroplating, right? Then so let's head on to see what are the other things contained in the lesson then. So you are given with a topic here, characteristics of a high quality electroplating. What are the characteristics of high quality electroplating? Number one, the layer or the plate should be firmly fixed to the object. Okay, metal layer should be firmly fixed to the object. Okay, so we can write metal layer plated layer should be firmly fixed to the surface. Plated layer should be firmly fixed to the surface. Next one is the layer which is plated, my dear children, should be, or it should have a same thickness throughout the object. Okay, plated metal should have a good thickness. I mean, like, not a heavy thickness, but it should have an even thickness, right? Thickness should be even throughout the surface. Okay, otherwise what will happen? If the thickness is not even, then there is a higher possibility of removing these things. Okay, so therefore second one would be plated layer should have a same thickness all around the object, right? So plated layer should have a same thickness all around the object. So all around the object, the thickness of the plated layer should be equal. Okay, it should be same. This is the second one, right? Then the third one would be, my dear children, you know that we are going to plate a certain different metal. Now this metal should have a shiny coating or shiny surface, right? To have an attractive look, right? To have an attractive look or to have an attractive color, we are going to plate this metal on the particular object. So the first and foremost thing is to have a good attractive look. In order to get a good attractive look, my dear children, the coating should be very shiny. Okay, so the coating should be shiny. That should be the next or the next process or the next example for a high quality electroplating. Coating or the plated layer should be shiny. Plated layer should be shiny. Right? It should be shiny. So these are the special points, or these are the special conditions that we can observe, or the features that we can observe in a high quality electroplating. Number one, plated layer should be firmly fixed or adhere to the surface. Next one, plated layer should have a same thickness all around the object. Then plated layer should be shiny, right? So these are the key characteristics that we can observe in a high quality electroplating. Okay, then the next one, okay, by reading out those, or by studying the previous things related to the electroplating, I'm going to write down the second conditions, or the second main condition which we need to consider about a good quality or high quality electroplating. What is that? So the conditions we need to follow for a high quality electroplating, right? The earlier was how to observe a high quality electroplating process. Now here, to have such kind of an high quality electroplating process, what are the conditions that we need to follow? Number one, first and foremost thing is the reaction that is going to happen, or that is going to occur, should occur very slowly. Okay, the reaction which is going to occur should happen, or it should occur very slowly. In order to occur a slow chemical reaction during the process of electroplating, we need to provide low potential difference, low electric current, and the solution or the electrolyte which is going to use should be dilute. Okay, so these three are the key main, or the main important conditions that we need to follow, right? So these three are the main important conditions that we need to follow. Once again, what are those? We should provide low potential difference to the circuit. We should provide low electric current to the circuit. Then the third one would be electrolyte which is used should be very dilute. So we'll write down the three conditions. Number one, electrolyte should be very dilute, right? Electrolyte should be very dilute. Number two, should provide low current. Should provide, we'll write minimum current. Should provide minimum current needed for the reaction. Should provide minimum current needed for the reaction with low potential difference. Voltage means potential difference, you know that, right? So we should provide minimum current needed for the reaction with low voltage or low potential difference. Then the third one, reaction should occur slowly. Reaction should occur slowly. Okay, we should allow to give more time, or else we need to allow to provide more time. By that way, the reaction, if the reaction time is going to increase, then my dear children, the quality of the plating process is also going to increase. Okay, I mean, like, the slower the reaction, the quality is going to be increased, or the quality will high. Okay, quality will be high. So these are the conditions that we need to follow, or conditions that should be satisfied by a system in order to have a good electroplating or quality electroplating. What are those? Electrolyte should be very dilute. The electrolyte which is going to use should be very dilute. Next one, should provide minimum current needed for the reaction with low voltage or low potential difference. Next one, reaction should occur very slowly. Okay, it should occur slowly. So these are the three main conditions which we need to follow, or which we need to follow, or which we need to provide when making a good quality electroplating process. Right then. So the next topic given, the applications of electroplating. Applications of electroplating. You are given with a point. Pay your attention to vases, trays, cutlery, and doorlocks offering a golden or silvery luster, which are being used at home. Very often, the luster of those objects is due to a metal layer deposited on them. In order to prevent rusting of the parts of motor vehicles, they are coated with thin metallic layer by electroplating. So most of the vases that we have in our houses, right, metallic objects like door locks, then different other materials like vehicle parts, they have a unique shiny nature because a certain metal is plated on them. Okay, here we use the process of electroplating to plate a certain metal object, or plate a certain metal on a particular object. Okay, so this electroplating is used in various industries like making vases, trays, medals, trophies, then vehicle instruments, then household instruments, then cutleries, and so on. So electroplating is vastly used to create different kinds of other metallic objects that has a unique luster, and that which are going to resistive for the corrosion. Okay, so electroplating is very important to make or to avoid rusting process of the iron and other different objects, my dear children. Okay, so here you are given with another point. Mostly metals like copper, silver, gold, nickel, and chromium are plated like this. So these metals have a good resistance, or they will provide a good resistance for the corrosion, and also they have a good luster. So because of having those features, these metals are plated on other objects. So these metals are resistant to corrosion. They have a good luster. And my dear children, the appearance, okay, or the nature of the substance is very unique, and they have a good quality. So therefore, these substances are often plated on the objects, right, on the other metallic objects, especially because of the resistant of corrosion. It's providing a resistance to corrosion, mainly because of that. Right, then the next point is given. In such instances, the metal plate has a certain property which is lacking in the metal which is subjected to plating, right? So if you take iron is quickly corrosive, or it is corroded very quickly, and it doesn't have a unique, lustrous nature. It has a lustrous nature, but however, because of the corrosion, the lustrous nature will disappear very quickly, and there is no colorful nature, or the color of the iron is not that much attractive. It doesn't have an attractive color. So because of having these attractive color, a good luster, right, attractive color and a good luster means the shiny surface, right, a good shiny surface, right, then because of having these shiny surfaces and a unique and a wonderful color, and also because of these metals are resistant to corrosion, right? These metals are plated on different other metallic objects, my dear children. So those objects, the metals which are made by those objects, right, will not have those features. That is why we are going to electroplate. So the special features of metals which used in electroplating. What are the special features? Number one, should have a good color. Right? It should have a good color. Then it should have a shiny surface. A shiny surface. You know that for the shiny surface we use the term called luster, right? It should have a good lustrous surface. This is the next one, right? It should have a shiny surface. Then number 3, it should be resistant. It should be resistant to corrosion. Right? It should be resistant to corrosion. So these are the special features that we can identify within a metal which is plated on a different other metallic object, right? What are the features? It should have a good color, right? It should have a good color, a unique color. Then it should have a shiny surface. Definitely it should have a shiny surface. Then it should be resistant to corrosion, right? It should be resistant to corrosion. So these properties are very important for a metal which to be electroplated on a different other metallic object. Right then, electroplating nickel metal on iron tray protects it from rusting and also gives it an attractive appearance. So like I said, my dear children, when you electroplate, it is giving out a certain, an attractive appearance, and as well as it protects from the rusting process as well. Electroplating a copper jewelry with gold adds value to it and gives a rich look. So you can make jewelry with copper or silver, somewhat cheaper, right? So by using the process of electroplating, now you can plate these things using gold. So when you compare the shiny nature of gold, it has a more shiny nature. I mean, the luster of gold is somewhat way more greater than the copper. So when you electroplate gold on copper, the shiny nature or the lustrous nature will increase, and also the color will also be unique. That yellowish gold color could be observed. Okay. However, you know that if you use copper, then the copper is having a brownish red color. Then if a certain person look at copper jewelry, then he or she would definitely identify that this thing is copper, right? So when you plate gold on that copper, right, it seems to be gold, it seems like gold, but however within the structure is made up with copper. Okay. However, we can observe it as gold because we are going to plate gold on the copper necklace by using the electroplating, okay, necklace or any other jewelry. So my dear children, here when plating jewelries with gold, right, it's going to be very cheap, and also the other thing is it's going to be right? It's going to give very attractive color, like same color and shine nature same as the gold jewelries. Okay, right. So here it is given, electroplating a copper jewelry with gold adds value to it and it gives a rich look. So here these are copper jewelries subjected to electroplating. Okay, and some electroplated kitchen equipments, cutleries, and here some electroplated spare parts like alloy wheels given here. Okay, right then. So these are the applications of electroplating. So my dear children, with that part we have came to the end of our lesson, right? So like usual, we'll discuss what are the special things that we discuss under this lesson, right? So we'll head on to see the summary of the lesson. Liquids or the solutions which conduct electricity are called electrolytes. So you know that electrolytes are the substances, liquid substances that can conduct electricity. The reason for electrical conductivity of electrolytes is the presence of mobile ions in them. So we discussed that within a solution, if it contains mobile ions, then it will conduct electricity. That is why it is referred as an electrolyte. Liquids or the solutions which do not conduct electricity are called non-electrolytes. They do not contain mobile ions. So non-electrolytes are the ones which do not conduct electricity, and also they do not have mobile ions. Though ionic compounds contain ions, they cannot move in the solid state. Therefore, solid ionic compounds do not conduct electricity. So we discussed that in the solid state, those ions are firmly fixed in an ionic substance or ionic compound. So therefore, in the solid state, ionic substances will not be able to conduct electricity. They behave as insulators in the solid state. However, when you dissolve these things in water or when you make a fused solution, these ions will segregate and they will help to conduct electricity. Okay, so ionic compounds only conduct electricity in solution or in liquid state. It can be any form, fused or aqueous. However, in the solid state, ionic compounds will not conduct electricity. Okay, next one. Aqueous solutions and fused liquids of ionic compounds conduct electricity. So we discussed that thing, right? Ionic compounds in the fused state or else in the aqueous state conduct electricity. The chemical changes taking place at the electrodes when an electric current is passed through an electrolyte is referred to as electrolysis. So electrolysis is the simple process of creating a chemical reaction by providing electricity to an electrolyte. Okay, so electrolysis is the process of making or creating a chemical reaction by providing electricity to an electrolyte. Next one. During electrolysis, chemical compounds are split into more simpler compounds or elements. So during the process of electrolysis, chemical compounds are split or separated into more simpler compounds or elements, right? Like we discussed under the acidulated water is getting converted into oxygen gas and hydrogen gas upon providing electricity. Or during the electrolysis process of acidulated water, water separated into oxygen gas and hydrogen gas. Okay, that means simpler compounds. Next one. By electrolyzing acidulated water, water can be turned into elements hydrogen and oxygen. Right. So by electrolyzing acidulated water, we can convert water into hydrogen and oxygen gas. Next one. Coating one metal with another metal by passing an electric current is called electroplating. So electroplating is the process of coating, right? It is the process of coating another metal on a different metal, right, by providing electric current. Next one. When electroplating, always the metal that is subject to plating should be kept the negative electrode. So when electroplating, always the metal that subject to plating should be kept the negative electrode. Then the next one. During electrolysis, the metal that is plated is kept the anode while a solution of salt of that metal is used as the electrolyte. What do you mean by anode, my dear children? Anode. So, for the positive and negative terminal, during the process of electrolysis, we use the term called anode and the cathode. Anode is the positive terminal. This is the positive terminal, right? Anode is referred as the positive terminal. It is the positive terminal of the electrolysis. Then cathode, next one is cathode. Cathode. Cathode means the negative terminal. Cathode is the negative terminal. So anode is the positive, cathode is the negative. So once again I am coming to the point given here. During electrolysis, the metal that is plated metal is kept at the anode. Anode means the positive. Yes, the plated metal should be kept at the anode, while a solution of salt of that metal is used as the electrolyte. Right? So the electrolyte that we are going to use should be the same salt of that particular metal. So let me go and check the other sentence once more. When electroplating, always the metal that is subjected to plating, that means the object, should be kept at the negative terminal or the negative electrode, which is referred as the cathode. Okay, cathode. So anode and the cathode. Right then. A high quality plating occurs when the chemical changes at the electrodes occur very slowly. So like we discussed in the earlier, right, when we are discussing about the features or the characteristics in a high quality plating, we discussed that if the chemical reaction is occurring very slowly, then the quality is very high. To obtain high quality plating in chemical industry, conditions are appropriately controlled. So like we discussed, the conditions are appropriately controlled in the industrial applications of electroplating. Okay. Next one. In electroplating, it is expected that the metal that is plated possesses superior qualities to that of the surface being plated. So the metal which is the metal which we are going to use in the electroplating process, okay, it should have distinct properties, or it should have superior properties rather than the metallic object. Okay, so therefore the metal that we are going to use is more often be like copper, silver, gold, nickel and chromium and so on. Okay, because these metals have somewhat unique properties rather than the other metallic objects, or rather than the other metallic elements. Okay, right. So these are the special key things that we have learned within the lesson part, my dear children. Now it's time to head on for the questions, right? So first of all, we'll start from the questions given in your textbook, right? So first of all, you have to select the correct or most suitable answer. So MCQ type questions. First one is given, what is the electrolyte from the given liquid or solutions? You have to take out the electrolyte. Distilled water. Distilled water is not an electrolyte, my dear children. Distilled water means, right, it's 100% pure water. If it is 100% pure water, then it is available only in molecules. Water is available only as molecules. There are no any ions in it. So therefore distilled water is incorrect. It is not an electrolyte. Sugar dissolved in distilled water, once again incorrect. Sugar solution, because we discussed that sugar is having covalent bonds, right? Covalent compounds. Ionic compounds are the ones which can conduct electricity. Covalent compounds, they can't. So it is incorrect. Sodium chloride dissolved in distilled water. This is the answer. Sodium chloride, like I said, it's very easy to identify ionic compounds. If it has a certain metallic name, then definitely it is a ionic compound. Sodium chloride. Sodium is a metal, right? You ignore about the other content. Check whether there is a metal in the compound. If there is, then definitely it is an ionic compound. Okay. Then the next one given, grease dissolved in kerosene. Once again incorrect. Grease and kerosene both are not ionic compounds. Okay. So solutions of ionic compounds are the ones which has mobile ions. So they are the ones who are referred as electrolytes. Next one. Petrol is not an electrical conductor because it does not contain mobile electrons. Its density is very low. It does not contain mobile ions. It is slightly volatile. So petrol is not an electrical conductor. It's not going to conduct electricity because, my dear children, as it is a solution, it doesn't contain any mobile ions, not electrons. Okay, electrons can be identified within metals. Okay, within metals we can identify mobile electrons, moving electrons. Okay, so here it does not contain mobile ions. This is the reason. So therefore petrol is not a good conductor. Number 3, select the correct statement from the following statements. Solid sodium chloride is an electrical conductor. Incorrect. We discussed that solids of the ionic compounds will not be able to conduct electricity. They should be made into a solution. Next one. Fused sodium chloride does not conduct electricity. Once again incorrect. If solutions of ionic compounds are used, then they are going to conduct electricity. So it is incorrect. Next one, an aqueous solution of sodium chloride conduct electricity. This is correct, my dear children, no matter whether it is aqueous or fused. Right? No matter whether it is aqueous or fused, ionic compounds, solutions of ionic compounds is going to conduct electricity. So sodium chloride is an ionic compound. So solutions of ionic sodium chloride will conduct electricity. So aqueous solution of sodium chloride will definitely conduct electricity. We'll check on the final one as well. Solid sodium chloride consists of mobile ions. Once again incorrect. If they have mobile ions, then they will definitely conduct electricity. Okay. So as they do not have mobile ions within the solid state, sodium chloride is not going to conduct electricity in the solid state. Okay. However, in liquids, they are going to conduct. Liquids means it can be a fused solution or else an aqueous solution. Then the question number 4. Which of the following statement is correct about electroplating? To make high quality electroplating, the concentration of electrolyte must be high. Incorrect. Concentration should be very less. Right? Concentration should be very less. To electroplate a copper ring with silver, copper ring must be kept as the positive electrode. Once again incorrect. Always the object should be at the negative electrode. Okay. Next one. Electroplate copper ring with silver. Copper plus salt must be taken as the electrolyte. Once again incorrect. If we need to plate silver, then we have to use the electrolyte of silver, not gold. Right? Not gold or copper. So here it is saying that to electroplate a copper ring with silver, copper salt must be taken. No. Copper cannot be used. If you need to plate it by using silver, then we need to use a silver electrolyte. When electroplating copper ring with silver, positive electrode erodes gradually. Erodes means, my dear children, dissolves. So it is correct, right? Positive electrode gradually dissolves and on the negative terminal, it's getting plated. So it is correct. So when electroplating a copper ring with silver, the positive electrode erodes gradually. It is correct. Right. So this is the correct statement out of these 4 sentences. Right. Then let's head on to the next one. You are required to coat a silver bangle with gold. Which of the following set of substances is more suitable for it? Silver rod. You are required to coat a silver bangle with gold. So you don't need a silver rod. No need. A gold rod. Yes. Very dilute solution of silver salt. Incorrect. We'll be needing gold with a dilute solution of gold, not silver. Because you are required to coat silver bangle with gold. So the bangle is silver and we are going to plate gold in it. So we need to use a gold plate with a solution of gold. Gold rod, dilute solution of gold. This is the answer. Next one, gold rod, concentrated solution of gold. What do you mean by a concentrated one? Concentrated means, concentration means actually the number of particles contained within a unit volume. So concentrated solution means large number of particles contained within unit volume. Okay, concentrated. Diluted means less number of particles contained within unit volume. So like I said, my dear children, to have a good quality electroplating, we have to use a very light color solution. Light color solution means the concentration should be very low. That means it should be very dilute. Okay. Sixth one, which of the following is not an observation of the electrolysis of copper sulfate solution? Not an observation. Okay. Decaying of the positive electrode, reduce the blue color of solution, deposition of copper on the negative electrode, liberation of gas bubbles at the positive electrode. Which of the following is not an observation of electrolysis of copper sulfate? Decaying of positive electrode, reduce the blue color of solution, deposition of copper, then liberation of gas bubbles. All of these three are correct. Which three? Number 2, 3 and 4. All of these are correct. Okay. Why is that? Because reduction in the blue color of the solution is going to happen because copper is going to deposit on the negative terminal. The unique blue color of the copper sulfate solution is obtained only because of copper ions. So if the copper ions are going to deposit as copper on the negative terminal, then the blue color will definitely reduce. So it is correct. Deposition of copper on the negative electrode, I explained that thing earlier, right? So liberation of gas bubbles at the positive electrode, it is also going to happen because I think you could remember, right? Oxygen gas is going to emit from the positive electrode when this thing is going to happen, or when the process of electrolysis is going to happen, right? For the copper sulfate solution. So my dear children, the third one is also correct. But however, we won't be able to observe, right? We won't be able to observe decaying of positive electrode because here we are using carbon electrode. Carbon electrodes are not going to decay because they are not participating in the chemical reaction. Okay, they are inert electrodes. Right then. So you have to give short answers. Name 3 electrolytes. So what are electrolytes? Electrolytes are the substances that can conduct electricity. Okay, those are the substances that can conduct electricity. Specialty here is that these are solutions. So we have to write down solutions of ionic compounds. How to identify ionic compounds? They should have metals. So we can write sodium chloride solution. Right? Sodium chloride solution. Rainwater. Rainwater, you know that rainwater contains different substances mixed in it. Sometimes it will contain different metals, right? Minerals. So therefore mineral water, rainwater, these substances going to conduct electricity. Next one, battery acid solution. So you know that battery acid solution means this is sulfuric acid. Each and every acid is a good conductor of electricity because they contain mobile ions. We discussed this thing under the examples of electrolytes, right? So sodium chloride solution, ionic compounds, rainwater, as it contains different kinds of elements and metals, it's going to conduct electricity. Then battery acid solution, you know that each and every acid is a good conductor of electricity because it has mobile ions. So battery acid solution or sulfuric acid solution is a good conductor of electricity, therefore it is an electrolyte. Next one, name 3 non-electrolytes. Non-electrolytes. Glucose solution, right? Glucose solution. Petrol, kerosene oil, right? So glucose solution, petrol, kerosene oil, these things do not contain, right? These things do not contain any mobile ions. So therefore these things are not considered as electrolytes. That means these things are non-electrolytes. Right. Write 3 observations when electrolysis of copper sulfate solution using inert electrodes. 3 observations when electrolysis of copper sulfate solution using inert electrodes. 3 observations. What are the 3 observations? Number 1. Oxygen gas is going to emit. Oxygen gas is going to emit from the positive terminal. Okay. Right. So here we can't say as oxygen gas because you have to write down the observations. No. So we'll write down gas bubbles emit from the positive terminal. Number 1. Gas bubbles emit from the positive terminal. Gas bubbles emit from the positive terminal, right? Gas bubbles emit from the positive terminal. This is the first observation. Number 2, second one. So the second observation, you know that copper is going to plate on the negative terminal, right? Copper is plated on the negative terminal, right? Copper is plated. Here we can say copper because it has a unique brownish red color. Copper is plated on the negative terminal. So copper is plated on the negative terminal. Number 3, as copper is plated on the negative terminal, the copper present or the copper ions present at the solution will disappear or it will reduce gradually. So therefore the unique blue color of the copper sulfate solution also reduces. So third observation, blue color of the solution reduces, right? Blue color of the solution reduces. This is the third, right? This is the third and the final observation. So what are the 3 observations? Gas bubbles emit from the positive terminal. Copper is plated on the negative terminal. Blue color of the solution reduces. These are the 3 main observations during the process of electrolysis by using copper sulfate solution. Right then. Name the gases liberated at the positive and negative electrodes during the electrolysis of acidulated water. Right. So here, always my dear children, try to memorize the things. Don't be like a parrot. Always try to read the things and keep those things in your mind. Try to memorize the things that we have learned. Don't always try to learn by your heart. Okay? Don't be a parrot. Try to memorize. That's how you learn science. So let's memorize like this. Water is degrading into, or water is divided into 2 main ions when you add acid. That 2 ions are OH minus and H plus. We know that hydrogen plus ions are observed at the negative terminal. That means, my dear children, definitely negative terminal, from the negative terminal, hydrogen gas should evolve. Why is that? Because only element present at the negative terminal is hydrogen. So hydrogen is going to emit from the negative terminal. Then we know that acidulated water, during the process of acidulated water electrolysis, hydrogen and oxygen are the ones, or hydrogen and oxygen are the two gases which is going to evolve. So if you know hydrogen is going to evolve from the negative terminal, definitely from the positive terminal, oxygen is going to evolve. So it is very easy, right? Try to remember these things. If you know these things, then you know where are these two ions at. So always positive ions are at the negative terminal because opposite charges are getting attracted each other, and the negative ions are at the positive terminal. So we can write the answer like this. We'll write down near positive terminal, right? Near the positive terminal, negative ions can be observed. That means OH minus is present near the positive. OH minus is going to evolve oxygen gas. Then near negative terminal, you can observe hydrogen gas. So oxygen gas can be observed near the positive terminal. Near the negative terminal, hydrogen gas can be observed. Next one. In addition to the liberation of gas bubbles at the electrodes, write an observation that can be made during this electrolysis. In addition to the liberation of gas bubbles at the electrodes, write an observation that can be made during this electrolysis. The other thing is that we can observe more hydrogen gas is getting collected than the oxygen. That means more gas bubbles are going to evolve from the negative terminal or near the negative terminal compared to the positive. That's the next observation, right? So we can write it. More gas bubbles emit from negative terminal or negative electrode. More gas bubbles emit from negative terminal compared to positive, or else we can write more gas bubbles emit from negative terminal but less in positive. Right. So this is the other observation. So in addition to the liberation of gas bubbles, more gas bubbles emit from negative terminal but less in positive terminal. That means we can collect more gas at the negative but less gas in positive terminal. Okay. Less amount of gas in positive terminal but more amount of gas in negative terminal. Or else you can write the gas collected, right? Gas collected at the negative terminal is approximately or is about 2 times the gas collected at the positive. That is also correct. But mention about, because actually it is not exactly 2 times, no. About or approximately 2 times. This is just an approximate value. Okay, estimated value. Right. So however we can say that more gas bubbles emit from negative terminal but less in positive. This is the other observation. Right then, my dear children. Write a simple test to identify the gas liberated at each electrode at the each electrode you have to write down, right, at the each electrode you have to write down a simple experiment to identify the two gases. Okay, so we'll write down number 1, oxygen gas. This is at the negative electrode. This is at the positive electrode, right? So oxygen gas at the positive electrode. So oxygen gas at the positive electrode by inserting a lighted splinter or else a glowing splinter will include when here when inserting a glowing splinter, the flame will be bright, or else we can write the flame will increase, and be bright. Right. So oxygen gas at the positive electrode can be identified when inserting a glowing splinter. The flame will increase and it will be bright. And also the flame will increase. Then the next one, I'll use a different color here. Hydrogen gas. This is at the negative electrode. At the negative electrode, hydrogen gas. So here, when a glowing splinter is inserted, right? When a glowing splinter is inserted, flame will put off by giving a pop sound. Right. So when you insert a certain glowing splinter to a container of hydrogen gas, what will happen? When a glowing splinter is inserted, flame will put off by giving a pop sound, right? So this is the observation that we can see when you insert a glowing splinter to a container of hydrogen. Okay, we did that thing in the laboratory as well. So these are the two ways of identifying the two gases. Oxygen gas can be identified when inserting a glowing splinter, the flame will get increased and it will be very bright. And hydrogen gas can be identified when you insert a glowing splinter, it will give out a pop sound and the flame will get put off. Okay, right. Okay then. Right, then the next one. Diagram shows an electrolytic cell used to electroplate a copper ring with silver. So a copper ring is plated with silver here. There is a solution of B in here also, right? Name a metal that can be used as the electrode A. So here electrolytic cell used to electroplate a copper ring with silver. Now silver is the one which we need to use as the electrode then. Silver plate, right? Metal that can be used as electrode is silver plate. Next one. What is the sign of the electrode A? Positive or negative? A is the electrode connected to the positive terminal because it has the longer terminal, right? So positive. Right? What is the sign of the electrode A? A is at the positive terminal. Which solution of a salt of which metal can be used as solution B, which is the electrolyte? So you know that if we are plating silver, then we need to use an electrolyte that has silver, right? Salt solution of silver, right? Salt solution of silver, right? Then the next one. What precautions can be taken to obtain a plating of high quality? So to provide or to get a high quality electroplating process, what are the precautions? What are the conditions that we need to follow? Number one, providing less current, right? Providing less current to the circuit. This is the first thing, because we have to slow down the reaction. So in order to slow down the reaction, we need to provide less current. Okay. Number two, taking a very dilute salt solution or electrolyte. Taking a very dilute electrolyte. So this is the second one. Providing less current to the circuit is the first one, and taking a very dilute electrolyte is the second one. Okay. So these are the two conditions that we need to follow. You can write if you want here, providing less voltage with less current, right? That is also okay. You know that when reducing the voltage, the current is also going to reduce. Okay, that's why I have mentioned only the current. So here providing less current to the circuit is the first precaution that we can follow, and taking a very dilute electrolyte is the second precaution that we can follow, right? With that question, my dear children, we have finished all the questions related to the textbook. Now it's time to discuss several MCQ questions, several extra MCQ questions related to the lesson part. Okay, so now let's head on to observe extra questions related to the lesson. Right, let's see the extra questions. You are given with the first one, an electrolyte is a solution that conduct electricity, metal that conduct electricity, non-metal that conduct electricity. So you know that electrolyte is a solution that can conduct electricity. So we can underline the answer, solution that can conduct electricity, right? Solution that can conduct electricity, solution. Next one, current flow through electrolyte is due to the movement of ions, holes, electrons, atoms. So current flow through an electrolyte is due to the movement of, you know that within an electrolyte there are things called mobile ions. So due to the movement of ions, right, ions, the current will flow through an electrolyte. Okay. What is the preferred electrode when it is not allowed to take part in the chemical reaction? Preferred electrode when it is not allowed, that means an inert electrode. Gold, silver, copper, graphite. Gold, silver, copper, all of these things involved in the chemical reaction, because you know that these things are going to melt or these things are going to dissolve and get plated on the negative terminal during the process of electrolysis. So the inert one would be graphite. Inert one would be graphite. Graphite means carbon rods, my dear children. Okay. Next one. What is the product formed at the negative terminal in the electrolysis of aqueous copper sulfate solution? Product formed at the negative terminal. Negative terminal. What is the product formed at the negative terminal? So we know that during the process of electrolysis of copper sulfate solution, copper metal is getting plated on the negative terminal. So our answer would be quite easy. Copper metal should be the answer, my dear children, right? Copper metal is getting plated on the negative terminal, right? So not oxygen gas, not hydrogen, sulfur, it's actually irrelevant. So the correct answer would be copper metal. So copper metal is getting plated on the negative terminal. Okay. What is the electrolyte used in electroplating of gold? Molten gold. Molten means, my dear children, fused. So we can't use fused gold, right? We won't use fused gold in electroplating process of gold, right? Fused gold solution, once again the same, right? Incorrect. Gold metal, again incorrect, because they are asking about the electrolyte. Gold cyanide solution, that's the correct answer, because in electroplating we have to use a salt solution of gold as the electrolyte. So they are asking about the electrolyte, not asking about the positive terminal. If the positive terminal is being asked, then gold plate is correct, okay, or gold metal is correct. So they are, as they are asking about the electrolyte, the correct answer would be gold cyanide solution. Next one, example for an ionic compound. Ionic compound contains a metallic substance, right? Ionic compound contains a metallic substance. So don't underline the metal given here, okay? Metals are not ionic compounds. Ionic compounds are made by metallic elements. So get a compound or select a compound that has a metallic element. Copper metal is incorrect because it is a metal. Oxygen gas, there is no metallic compound. Sodium nitrate, this is our answer. Sodium nitrate. Sodium nitrate. You just ignore about the chemical name. Don't think about that too much. Just think about the metal contained in it. If it contains a metal, then it is ionic. So ignore about the nitrate thing. As it contains sodium, it is ionic. So example for an ionic compound is sodium nitrate. Metallic electrode which do not take part in an electrolytic reaction. Metallic electrode, that means it should be a metal. So gold, silver, copper, all of these things will get dissolved and get deposited on the negative terminal during a electrolysis process. However, my dear children, platinum will not, right? Platinum will not. It's because platinum is an inert electrode. Next one. Which of the following act as non-electrolyte? That means a solution which cannot pass electricity. Okay. Next one. So see, sodium hydroxide aqueous solution. Sodium hydroxide, as it is a ionic compound, incorrect. Liquid carbon tetrachloride. Let's go for the other ones. We don't know about carbon tetrachloride, right? We don't have any kind of a clue. So we'll head on for the other answers, okay? Potassium chloride, as it contains potassium, right? Potassium is a good metal, so it is incorrect. Acetic acid solution. Don't think about this type of acid. However, it is an acid solution, no. So it is incorrect. We discussed that all the acids are going to conduct electricity. So that means those things are electrolytes. So our correct answer would be which one? Carbon tetrachloride. Most of the children, right? Most of you children will look at this question. And now you might think that we don't know about carbon tetrachloride. I don't know about carbon. Now, some people might think like that. I don't know about carbon tetrachloride. I never heard about carbon tetrachloride. So, I won't be able to answer this question as I don't know about carbon tetrachloride. But however, it is irrelevant. Why is that? Because when you eliminate the things which cannot be an answer, the remaining one should be the answer. It's quite obvious. Okay. So, according to the things that we have learned within the lesson, we have neglected or we have removed the other answers which cannot be a certain response to this particular question. So by that way, we took the correct answer. Okay, sometimes these types of questions will come. A chemical substance or any kind of a thing will be given for you guys which you have never been heard. Okay, but however, all the others which are being mentioned are being learned. Oh, these things you have already learned. In that case, you should have the knowledge to ignore or neglect whatever the responses or whatever the response which is not a possible answer, and by that way you should have the ability to select the correct possible answer for the question. Okay, that's what I did in here. So you don't think about the contents, just think about the possibilities. Okay, right then. Inert electrode is inert electrode. Once again the same thing like this. See, in here metallic electrode which do not take part in electrolytic reaction. That means the metal is not reacting with the electrolyte. It means it should be inert, right? It should be inert. So my dear children, inert electrode is platinum. So here directly it is given as the inert electrode. So it's very easy, no? Both the questions asking or referring the same thing. But however, you should know what do you mean by the term inert. Inert means less reactive or no reaction at all. So correct answer would be platinum. Next one. In solid state, sodium chloride is we discussed this thing. It's a good insulator because in the solid state, my dear children, the sodium chloride or the ionic compounds will not be able to conduct electricity. So it is a good insulator. Next one. If an object has to be plated with silver, then object must be at. If an object has to be plated with silver, then the object must be at negative terminal, right? Negative terminal. It should be at the negative terminal, right? So, not at the positive terminal. Positive terminal should be the silver plate. Then negative or positive both we can't in the solution. Of course, it is in the solution, but however, should be connected with the negative terminal. So the appropriate answer would be negative terminal. So object has to be plated with silver, then object must be at the negative terminal. It should be at the negative terminal. Next one. Electrode which is connected at negative terminal of battery is also called, very good question. Electrode which is connected at the negative terminal electrode is also called as cathode, my dear children. Cathode. Anode is the positive, cathode is the negative. So cathode, right? I'll mention the anode as positive here, cathode is the negative one, right? Cathode is the answer. So electrode which is connected at the negative terminal is the cathode. It is the cathode. Next one. Indicator of an ammeter deflects when a solution is connected with the dry cell. Reason for this is indicator of an ammeter deflects when a solution is connected with the dry cell. When a solution is connected with a dry cell, the indicator of the ammeter is going to deflect. It means there is electricity passing through the ammeter. That means solution conduct electricity. Solution can pass electricity, yes, that should be the answer. Solution is not passing electricity, incorrect, due to a defect in the ammeter. Not at all, right? None of the above. So our correct answer would be solution can pass electricity because the solution is behaving like a electrolyte. Next one, pure water within brackets given distilled water is an electrolyte. Incorrect. It is a non-electrolyte. It is a non-electrolyte because pure water or in distilled water there are no any mobile ions. Next one, solution that does not conduct electricity is called solution that does not conduct electricity. If a solution is not conducting electricity, then my dear children, it is referred as a non-electrolyte. Then it is referred as a non-electrolyte. Non-electrolyte is the solution which do not conduct electricity. Okay, it is the solution which do not conduct electricity. Next one, kerosene oil is a non-electrolyte because it does not contain atoms, does not contain mobile ions, does not contain ions, none of the above. Actually, kerosene oil is not an electrolyte because you know that it doesn't contain mobile ions. It does not contain mobile ions. It contains atoms, but however, it do not contain or it does not have mobile ions. Okay, there are no any mobile ions in kerosene oil. So therefore, kerosene oil is not a good conductor of electricity. So therefore, it is a non-electrolyte. It is a non-electrolyte. Next one, not an ionic compound. Not an ionic compound. Sodium oxide, gold nitrate, silver sulfide, sulfur oxide. Very simple, my dear children. Once again, eliminate all the things which cannot be a possible answer. Then the remaining one should be the answer. Ionic compound, we know that when you are writing a name of an ionic compound or when you are pronouncing a name of an ionic compound, we can find out a metal. So sodium metal, gold metal, silver metal, sulfur oxide, sulfur is a nonmetal, oxygen is a nonmetal. Then my dear children, answer would be sulfur oxide. Not an ionic compound. Okay, it is not an ionic compound. State of ionic compounds in room temperature. Usually ionic compounds can be available in the room in room temperature or else in normal environments. Ionic compounds, all ionic compounds are available as solids, right? They are available as solids. In order to make solutions, we have to dissolve it in water or else we have to make into a fused solution by heating, right? An observation in above setup is, now you are given with an setup here. So here copper sulfate solution is used. 2 carbon electrodes, negative electrode and the positive electrode is there. Okay, so this is the copper sulfate solution, the electrolysis of copper sulfate. Let's see. Deflection of the ammeter, absolutely correct. It is an observation because current is passing, no. Emitting gas bubbles from positive terminal, right? From the positive terminal, gas bubbles are going to evolve. Once again correct, because from the positive terminal, you know that oxygen gas is going to emit. So it is correct. Depositing brownish substance at the negative terminal. Once again correct. Brownish color substance is getting deposited at the negative terminal. That is copper. Then all of these things are correct. All of these things are observations of that setup. The gas emitted from the above setup is, the gas which is getting emitted is the oxygen gas. We discussed that thing when we are discussing the previous question, my dear children. here the oxygen gas getting emitted from the positive terminal, right? Oxygen gas. Right. Application of electrolysis. A certain application of electrolysis, electroplating, for the production of caustic soda, extraction of sodium, all the above. Electroplating correct, caustic soda production is correct, extraction of sodium once again correct. So all of these things are examples, right? All of these things are better examples for the for the applications of electrolysis process. Chemical name for caustic soda: sodium hydroxide, sodium chloride, sodium nitrate, sodium oxide. Chemical name for caustic soda, my dear children, sodium hydroxide. Chemical name for common salt is sodium chloride. Chemical name for caustic soda is sodium hydroxide. Sodium hydroxide. Right. Special property of a metal which is used in electroplating. Special property of a metal which is used in electroplating. Ability to conduct electricity. Incorrect, right? Irrelevant actually. Having a good sonority. Once again irrelevant. Sonority means giving out a good sound, a ringing sound when struck on an object. It is irrelevant for this thing, right? Next one. Being ductile. We know that all the metals are ductile, right? Attractive color, yes. As it is having an attractive color, we can plate this metal on a particular object, okay? Next one. Gas which emits from negative terminal during electrolysis of acidulated water. Gas which emits from negative terminal during the electrolysis of acidulated water. So you know that H plus, right? H plus, hydrogen plus ions can be observed at the negative terminal. So at the negative terminal, definitely hydrogen gas is going to emit. So our correct answer would be hydrogen. At the positive terminal, oxygen gas. At the negative terminal, hydrogen gas. Right. So gas which emits from the negative terminal during the electrolysis of acidulated would be, acidulated water, my dear children, would be hydrogen gas, right? Hydrogen gas. So always remember, water is getting separated into H plus and OH minus. This is getting attracted to the negative terminal. This is getting attracted to the positive terminal. So this one creates hydrogen gas, and this one is going to create oxygen gas. Okay. So from the negative terminal, hydrogen gas is going to evolve. Okay. Hydrogen gas is going to evolve. Right, my dear children. So let's head on to the next one. Benefit of electroplating. Benefit, that means an advantage. Ability to conduct electricity. No point of conducting electricity, right? There is no point. There is no such benefit. Okay. Resistant to corrosion. Increase in ductility. Having high rate of corrosion. So benefit of electroplating would be resistant to corrosion. Right? Resistant to corrosion. Ductility will not get increased. And also, definitely it will not have a high rate of corrosion, right? Actually, we are going to maintain the corrosion or going to reduce the corrosion here. So the correct answer would be resistance to corrosion. Gas which emits from positive terminal during electrolysis of acidulated water. Now, I think previously we took that answer, right? Here, see, negative terminal, hydrogen plus is getting attracted, so it emits hydrogen gas. Positive terminal, hydroxide particles or hydroxide ions are getting attracted to positive, so it will emit oxygen gas. So the question is asking what? Gas which emits from positive terminal during the electrolysis of acidulated water. OH minus is at the positive terminal, so it will create oxygen. Next thing, characteristic of high quality electroplating, ability to conduct electricity, right? Having uniform thickness, getting removed when touched, having high rate of corrosion. Characteristics of high quality electroplating. So a feature of high quality electroplating is having a uniform thickness, right? Having a uniform thickness all around the object. Next one, a good example for an electrolyte: rainwater, distilled water, sugar solution, coconut oil. Good example for an electrolyte is rainwater, my dear children. Distilled water is not a good conductor of electricity as it doesn't have any kind of a mobile ion. Then same for the sugar solution and also for the coconut oil as well, right? Then the next one, a metal that extracted by electroplating. By the process of electroplating, a metal which is extracted: iron, gold, silver, aluminium. We know that aluminium is getting extracted by the process of electroplating, right? Okay. To have a quality electroplating process, current provided must be high. Incorrect. To have a quality electroplating, current should be low. Current provided must be low. Yes, this is the answer. High potential difference in the electric source. Once again incorrect. High concentration in electrolyte which used. Once again incorrect. So in order to have a quality electrolysis process, what we need to do is we need to slow down the reaction. So to slow down the reaction, we can reduce the current, we can reduce the voltage, or else we can use less concentrated electrolyte or diluted electrolyte. Okay, right then. So we have discussed 30 extra questions, 30 MCQ questions related to the extra questions part, my dear children. In the next chapter, we'll be discussing somewhat few other extra questions also, right? So however, I'll be teaching or I'll be covering those questions in our next chapter. So stay with me till the end of the next chapter. We'll be discussing even more questions related to the lesson electrolysis.
To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.